instead of surface area. All right, so turn your chairs to the front of the room. And I think now at every table, everybody's filled up box 4. I'm actually going to record this. So you could, you know, there's been some absences and we had a little trouble with the smartboard in the other class. So hopefully I can get kids to catch up by looking at this. Angel, you need to turn around. All the way. Thank you. Okay, so how many cubes were in the box now, Kate? 24. And so that's the volume of the box. So we would say this box is 24, and those are little centimeters cubed, so we put centimeters with a 3. And the way you read that is 24, you know, cubic centimeters. So the word cubic means volume. Yes, even if it was a triangular shape. Just like triangular shapes that are flat, we try to figure out how many squares fit in it. With the idea that you could cut them off or whatever. Volume can even be liquid things, but we still think about volume as how much three-dimensional objects can fit in it, and our unit of measure is a cubic centimeter. Does that make sense? So when you look at box 4, you know, the way I made this picture is there was a bottom level and a top level, right? So for this box 4, if you could count how many squares are on the bottom level, you know, and I could do that by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares, because each one of those smiley faces is on top of one cube, okay? And so if I take a second box, a second level just like the first, I could just double it, right? So a little hard with the smiley faces, but basically if we know there's 12 there, then we could stack a row on top of a row and we get 12 plus 12 or 24 cubes. Check.
So does your volume be like length times width times height?
So for volume, it's a great question. Can you do length times width times height? Sometimes. You can always do length times width times height when you have a rectangular prism, but not for every other shape. So let go of the cubes. I know they're distracting, because that was a really important question. What did he just ask?
Can you do length times width times height?
For volume.
Yeah.
What's the answer, Zofia? Sometimes. So when can you do it, Jaspreet? And when, what would be an example when you can't do it? Sean? For a triangular prism. Right, for a triangular prism. Or for a hexagonal prism. So we've talked about other kinds of prisms. This length times width times height works for volume when it's a rectangular prism. Okay, so we're going to pause there for a minute. You guys are going to find page 82 in your book, and so am I. And here on 82, it's kind of like what you just did at your table. It's asking you to figure out the volume made from these centimeter cubes. So really quickly, just, I want you to answer, and you could do on scratch paper, just answer 1 and 2. We're not going to worry about surface area. We've practiced surface area a whole bunch. We're going to take a break from that today. So take a moment for prism 1, 2, and 3 and answer problem 1 and 2. Okay, you don't have them done? Who's got them done? Raise your hand. Okay, so turn around and face the front of the room again. What'd you get for all 3 of them? Prism 1, Kate?
We got the length of 5 and the width of 4.
So the length is 5 and the width is 4.
And height is 1.
And the height is 1?
Yeah.
And what's the volume?
The volume is 20.
The volume's 20. And there's 20 little cubes. Can you see the cubes in here? I can't get my board perfectly oriented, so It's a little hard for me to trace them today like I normally can. But can you guys see there's 20 cubes there just by counting?
Yeah.
Okay, and then if we look at Jack's method, plot Jack's method for right now, although Jack, there's been a lot of people like you that use this method. This method only works for what kind of prisms? Rectangular. You could do length times width times height, so we're sort of testing out the method, and make sure that you get the same answer using the method, right? Okay, Charlie's table. What about prism 2? Okay, 5, 4, and 2. So the length, that would be his length is back in this direction, right? 5, the width, 4, and the height, 2. So in case you have a little trouble seeing where I'm getting those numbers, I tried to put the red in there. And so the volume then, volume is 40. So that is correct. It's 40 what? Cubic centimeters, right? So the volume of this is 40 cubic centimeters. Well, that's harder to see. Let's try, maybe the green, yeah. A little hard to see. Trying to get it in there with it. There we go. I guess green's okay. All right, and also, you guys, did you notice it's just two of these?
And then the next one is
Right, it's just 2 levels, right?
and then the next one is 5.
Yeah, so without answering all the questions, you like that pen?
Yeah.
Even though we could go the long way here and say the length is 5 and the width is still 4. Now the height is 5. So we could do the rule, length times width times height. But we could also say we already knew this was 20, and there's 5 levels of it. And that's what, Jake? It's 100 what? Centimeters cubed. So raise your hand if that makes sense. Okay. So technically, your book and most teachers would call that 2 different methods. I'm not, and the reason is when you take a look at the 2 different methods, one method works for only rectangular prisms, and the other method works for all prisms. So we're going to take a minute, and I'm going to pause this. I want you to go to the next page and read part B, which is pictured up here, but I think it's on page 83 or 4.
Yeah.
Okay. So the question is it the same method? They're not really the same. So look at this method up here, this one. This kid does what Jack does. He just does length times width times height. So he's just using the 3 dimensions. What Natasha does is what you guys did in the beginning of class, where you find the area of the base, the 1 level, and then you count how many levels you have. I know those seem the same. The reason we the book makes them sort of as different methods is so you remember that one method only works for rectangular prism, and when we go to other prisms, you can't use length times width times height, but you could always use area of the base times the height. So, yeah, it's like you're reading my mind. Okay, so the formula for that would be this. So that's what I want you to do, is I want you to write this down in your notes. 2 methods. So method A would just be kind of what you probably learned in elementary school. But method B is really what you use when you get to more advanced math. Like you will start hearing people, teachers and students talking about volume as, you'll see it written with a capital letter, but what they really will be saying is volume is They won't say volume's length times width times height, because it's not always length times width times height. But it is always the area of the base, and we represent that with a capital V times the height. So it's whatever the base shape is, that area times the height. So if the base shape is a triangle, you find the area of the triangle and times it by the height. You get that? But today we're going to just focus on rectangular prisms. But I'm telling you both methods because eventually we focus on more than one type. Okay, so write that down. Brittany, that's you too. And then let's take some time to answer the questions in B, or in part B. We can talk about those questions over here. So for question B1, the author asked you if both strategies work. Right? They do. Okay? So we could just put a yes there. That's not a very interesting question since we just spent time talking about it. And B2 was the formula. So what I want you guys to do is B3. And on B3, I think some of you guys need to learn how to draw prisms. So I was going to take a minute to show you, how to do that. Because some of you naturally can draw them, and other people struggle with this. So B3 asks you to find the volume of a rectangular prism. When you're asked that, you should practice drawing the pictures. Chloe, you need to turn around and pay attention. Okay, and the dimensions they give you are a 12 by 10 by 7. So you guys should be able to draw a picture in 3 dimensions. Okay, so one way to do it is draw a parallelogram first. Right? You're just going to sketch out a parallelogram. And I'm going to try one more time. Like you guys, I'm not an artist. Some of you might be, some of you may not be, but we could all take time to get a decent parallelogram. So draw a parallelogram. Do it. Try this. Try drawing a prism. And then draw 2 vertical lines straight down. Just like that. Okay? Then connect the bottom. So far, so good? Go to this upper right corner and draw straight down again. And try to make it the same height as the first ones. And connect these corners. This line that I'm drawing should be parallel to the one above it. Do you see that? Now take this back corner
And draw to the...
and do a dotted line. So you guys that are following along, this is a good visualization skills. There's a few of you that are not following along. You might need to do this on a quiz or a test, so I would practice on your own there. Okay. The dotted lines show the hidden side. So, right, you're going to also connect the bottom of that dotted line straight across to line up with this corner, and then to line up with this corner. So it's just a good skill to practice. A lot of kids like to do this because, it's just fun to learn how to draw things. Now, if they say this is 10, and this is 12, and this is 7, even though my picture's not perfectly proportioned, it's a good visual that I can think of to help me solve the problem, especially if I also had to do surface area. If I give you just a description and not a picture, you should be able to draw the picture. Good question. So if this were a quiz question, this is about what I would expect for a perfect score. Not beautiful artwork and not all of these lines. That would just make some of you crazy and it defeats the purpose. It's more, can you visualize and draw a box? So now how do you do the volume there? So what would you do, Scout?
To find the volume,
Yeah.
I would do 10 times the depth times the height.
Okay, so you would
I
go
mean, the depth times the width. So 10 times 12.
10 times 12.
So it's 10 centimeters.
Yeah, so he's kind of visualizing the area of the base, even, you know, even if it's still, he gets that 120, and then he multiplies by the 7. So it's 12 times 7 is 84. So this isn't 840, and it's centimeters cubed because your book told me, although I didn't record this, now I have, that each of those dimensions were centimeters cubed. That's the basics of your homework tonight, okay? The thing that's different is you have to also do fraction multiplication, and I know it's been a while for some of you. So see the example over on the board? I want you to do example 1 in your notebook, and I'll put it here while you do your work. The reason I picked this problem was because a lot of people had trouble multiplying fractions, and we haven't practiced them in maybe 3 or 4 weeks. So remember, when you do fraction multiplies, it really helps some of you guys to use that area model. So I'm going to do 4.5 times 3 1/4 first. Okay? So this, I'll just put to make 4.5. I'll make this my 3 1/4. I'm just doing a visual area model. So what's 4 times 3?
12.
Yep. And how about a fourth of 4?
8, 10, or 12, 4, 16.
What's 4 times 1/4? Think about that again. Remember the trick was we put the little 1 here. We multiply the numerators. So we would get 4 times 1, which is
4.
And then 1 times 4, which is
4.
So what's 4 times a fourth?
1.
1. Remember, you have to know how to multiply fractions all your life, even though we stopped doing it for a week or 2.
I got it.
Okay, what's half of 3? Yes, Finn.
1.5.
1.5. Good job. And then half of a fourth.
Oh, it's 8.
An 8. Raise your hand if you remember how to multiply fractions.
Wait, I got that right? I changed them into decimals.
Yes, but I want you to be able to do both, because what if you don't have a benchmark fraction? And you can't change it into decimals. So 4.5 times 3 1/4 is 12, 13, 14.5, plus an 8th, right? So that's 14 and
5/8.
4/8, good job, plus 1/8, which is 14 and 5/8. And now I have to multiply that by 2.5. That's kind of a big giant problem. Now you have to do it again. So this is 14 and 5/8 and 2.5. What's 2 times 14?
28.
28. What's half of 14?
7.
7. What's 2 times 5/8?
Whoa. Oh, 2 times 5 is 10. I know.
10/8, which is 1 and 2/8,
1 and 1/4.
which is 1 and 1/4.
So it's.
I'm going to do 10/8, and then I'll put 1 and a fourth.
36 and 1/4.
And what's half of 5/8? 5 somethings. What? 5 16ths. So my total volume of that picture is 28 and 7 make 35. Plus I have that other one, 36 and a fourth, plus 5/16. So now what do I have to do?
You have to convert 1/4 to 16, which is 4/16.
Right.
9/16.
Okay, so I'm going to tell you that you have a little bit of fraction work tonight, but not quite this big. That being said, you should be able to do that kind of as the end of unit test. So if I shrink that up and look at that here, giant problem, I will post it. So there's a little bit of fraction multiplication.
Are we allowed to